All right, welcome to The Explainer. Today, we're going to peek under the hood of Ceph, which is one of the world's most powerful distributed storage systems. We're going to break down how all its core components work together to manage just an absolutely insane amount of data. I mean, have you ever really stopped to think about it? How do these huge cloud services store what feels like an infinite amount of your photos, your videos, your documents, and somehow never lose a single file? How are they dealing with thousands of hard drives failing every single day? Well, the secret isn't some magical giant hard drive. Nope, it's actually the exact opposite. It's a highly coordinated team of specialized software components, and each one has a very specific job to do, all working together in perfect harmony. And in the world of Ceph, that team is pretty legendary. So let's meet this super team. We're going to break down the role of each member, from the brains of the operation all the way down to the muscle that's doing the heavy lifting. And trust me, understanding this team structure is the key to getting why Ceph is so incredibly powerful and resilient. But hang on, before we can meet the individual team members, we need to understand the ground they all work on, the very foundation of the entire system. And that foundation is called Rados. And honestly, this car analogy, it's perfect. Rados isn't some single component you click on or interact with directly. Think of it as the engine, the chassis, and the transmission all rolled into one. It's this powerful, self-healing fabric that everything else is built right on top of. The name itself really tells the whole story. Rados, reliable, autonomic, distributed object store. Reliable because it's designed to never, ever lose data. Automatic because it's self-managing. It automatically handles failures and balances data on its own. And it's a distributed object store, which is the real secret to its massive scale. Everything you do in Ceph, whether you're storing a photo or running a whole virtual machine, ultimately becomes an object that Rados manages. Okay, so with that foundation laid, let's meet the three essential components that every single Ceph cluster needs to function. Think of them as the absolute core of the team, the brains, the muscle, and the indispensable assistant. First up, we've got the Ceph monitor, or MON for short, and this, without a doubt, is the brain of the entire operation. Now, it doesn't store any of your actual data, but it knows everything about the state of the cluster. So the monitor's job is to maintain the master maps of the cluster. It knows which drives are up, which ones are down, and where all the data is supposed to be. It is the ultimate source of truth. And here's the absolutely crucial design choice. Monitors never ever touch your actual data. By only acting as these lightweight managers, they avoid ever becoming a performance bottleneck. So how do you get multiple brains to stay in sync without arguing? Well, they use a process called POXOs, which is essentially just a democratic vote. One monitor gets elected as the leader. When a change needs to happen, like a drive failing, the leader proposes the change, and then the others vote. If a majority, what we call a quorum, agrees, then the change is committed. This whole process guarantees that every part of the cluster is always working from the exact same playbook. So, if the monitor is the brain, who's doing all the heavy lifting? Well, that would be the Ceph OSD, the muscle of the cluster. This is the component that does all the physical work of storing your data on actual hard drives or SSDs. The OSDs, these are the workhorses. You typically run one OSD process for every single disk in your cluster. They're responsible for storing the data, sure, but they're also incredibly smart. They handle replicating the data to make sure it's safe, they automatically recover from failures, and they even perform regular integrity checks to prevent silent data corruption. And, crucially, clients talk directly to the OSDs. This direct line of communication is the key to Ceph's incredible performance. Now for our third core member, the Ceph manager. You should think of the manager as the indispensable assistant to the monitor. It handles all the tasks that are important for managing the cluster, but not so critical that they need to burden the brain. So what does this assistant do? Well, it collects all the performance stats, like IOPS and throughput, from potentially thousands of OSDs. It hosts that beautiful web dashboard and API that administrators use, and it runs a whole ecosystem of plugins. By offloading all this work, it keeps the monitors free to focus on their single most critical job, maintaining the cluster state. And right here, this is where the manager's role becomes the most visible. When you log into the Ceph dashboard to check on the cluster's health, see performance charts, or create a new storage pool, you are talking directly to the active manager daemon. It provides the human interface to this whole complex system. And this gets to a really critical design difference between the two. The monitor is the brain. Without it, the cluster literally halts to protect your data. But the manager is the assistant. If it fails, the cluster keeps on running just fine. You just lose your dashboard for a moment until a standby one takes over. This separation of duties is just a masterful piece of engineering. So we've met the core trio that's always on the job. But sometimes a project requires a specialist. And in Ceph, when you need to provide a traditional file system, you call in the librarian. The Ceph MDS, or metadata server, has one very, very specific job. It manages the metadata for the Ceph file system, which is known as CephFS. It's kind of like a librarian who doesn't hold any of the books themselves, but knows exactly where every single one is on the shelves. And it's so important to remember this. You only need the MDS if you're using CephFS. The MDS handles the directory tree, file names, permissions, folder structures. It keeps all of this hot information in RAM for lightning-fast lookups, while the actual file data, the books, are still stored by the OSDs. Okay, so we've met all the key players. We have the foundation, Rados, the brain, the monitor, the muscle, the OSDs, the assistant, the manager, and the specialist librarian, the MDS. Now let's see how they all actually work together in a real-world scenario. Imagine for a second that you're a client, maybe a web server or a virtual machine, and you need to access storage. How do you tap into the power of this super team? Well, it's a surprisingly elegant and really efficient process. So here's how that first handshake works. The client contacts a monitor, the brain, and says, hey, I'd like to access the cluster. The monitor checks its credentials, and if everything's good, it hands the client the latest copy of the cluster map. And here's the magic. From that point on, the client barely even talks to the monitor again. It uses that map to communicate directly with the OSDs for every single read and write. But how does the client know which of the maybe thousands of OSDs to talk to? That is the secret sauce, the crush algorithm. It's a brilliant mathematical formula. Instead of asking some central server where the data is, the client simply calculates it. It takes the name of the data object, plugs it into the crush formula, and the answer tells it exactly which OSDs to talk to. This is what allows Ceph to scale almost infinitely without any bottlenecks. So there you have it. You've got a team of specialists, each with a distinct and vital role, all built on a self-healing foundation and coordinated by a brilliant mathematical algorithm. It's a design that provides incredible scale, incredible performance, and resilience. So the real question is, now that you know how it all works, what could you build with it?